This is Dongkyun Kim from KISTI, South Korea, and I'm very glad to be here to talk about Creonet softwareization project with the focus on ONOS VDN and Kubernetes orchestrations for cloud-native networking over Creonet S infrastructure. So here are the contents of my talk. Let me briefly introduce the Creonet and Creonet S in the first place, and then move on to the virtually dedicated networking and automated and end-to-end network orchestration technology development by KISTI with some use cases. Okay, so this is a Creonet infrastructure. It is the advanced national research and educational network in Korea, and it has nationwide 17 gigapops and 4 international networking centers in the United States, China, and Europe. Actually, it is providing up to 100 gigabit per second network connections for domestic and international RNE organization. And we recently started to migrate this traditional Creonet infrastructure and services for more open, virtualized, automated, and intelligent network environment based on Creonet S project. So Creonet S means Creonet softwareization. And the main goal of Creonet S is to become the first nationwide and international SN-centric wide-area networking environment for advanced RNA community in Korea, providing new user services and experiences based on virtually dedicated and automated networking and orchestration technologies. And it has a layered architecture with 4 principal building blocks like this. So infrastructure layer, control layer, virtualization layer, and orchestration layers. So as you can see here, here is the Creonet S building blocks. So the first building block is infrastructure layer. That is based on open flow centric SDN wide area networking environment that is deployed over 5 locations in Korea and 3 locations in the United States and China at this moment. And this infrastructure is controlled and managed by 3-node ONOS cluster with the distributed core feature supported by ONOS, actually mainly for high availability, scalability, and programmability. And those 2 very basic and principal SDN layers are stacked with 2 more actually virtualization and orchestration layers developed by KISTI. And so we implemented virtually dedicated networking applications in order to support dynamic on-demand virtual dedicated networking provisioning for this virtualization layer. And on top of virtualization layer, actually, we wanted to provide automation and intelligence via orchestration layer for end-to-end automated actually orchestration between VDN and Kubernetes. So here is the up-to-date deployment status of Creonet S over domestic infrastructure and international infrastructure of Creonet S. So as you can see here, here are 2 individual network domains, control domains. So Korea to United States domain and Korea to China domain. The main domain is Korea to United States domain, and this domain is running open flow, core, and edge network devices over Creonet S infrastructure. And a lot of, many of, end hosts actually interconnected to this global network topology based on those core and edge network devices. And 3-node ONOS cluster is now controlling and managing the whole global network topology of this domain at this moment. So let me actually introduce those layers one by one from here. So Creonet S infrastructure is actually started to be deployed in 2015. And since, until 2017, we completed the deployment of Creonet S in 6 locations in the United States and Korea, such as Seoul, Daejeon, Busan, Gwangju, and Changwon cities in Korea and Chicago in the United States. And since then, we have deployed Creonet S in 2 more locations in the United States and China. And actually, in a joint effort with Pacific Northwest Gigapop in the one of the research network in the United States, in Seattle. And another one was actually deployed in Hong Kong at the Mega Advantage Gigapop. So specifically, the Hong Kong domain, China domain, is actually now operational with its own controller. So we have two individual and different actually SDN control domain running on Creona S right now. And this actually China domain is now interconnected with the main domain of Creona S using the VDN federation technology, which will be introduced a little bit later. And the Creona S control layer actually now consists of two different owners versions, such as Nightingale release for Korea to United States domain and Loon release for China, actually Korea domain. So, and each domain actually is now adapting the distributed core functionality of owners to support very stable and reliable operations of control layer of Creona S right now. And we implemented virtually dedicated network applications on top of ONOS using the APIs exposed by ONOS controller, I mean Java APIs. So we actually developed the VDN to provide the user-based dynamic on-demand virtual network management based on a very intuitive graphical user interfaces for virtual network creation, update, and deletion by users themselves as well as administrators. So using those implementation, the VDN can provide logically isolated and dedicated networking with very high performance up to 100 gigabit per second guaranteed, and a certain level, I mean higher level of network security provisioned as well. And we actually implemented the first version of VDN as prototype in 2015. And the next year, we released the beta version. And finally, actually, the official version of VDN 1.0 was actually created in 2017. And last year, we updated and upgraded VDN to the version of 1.1.4. And at that time, VDN O Orchestrator was implemented as well. And recently, we updated the VDN to 1.2 version. And the overall functional architecture of VDN is like this. Actually, it has four principal building, so core actual building blocks, like a core engine here, core engine here, and graphical user interfaces, and actually the data stores, and several external systems interconnected to the data store as well. So those are ID federation systems and status monitoring systems. And the core functionality of the VDN architecture is tightly integrated to support the stable and the reliable virtual network slicing services for our users of Creona S. And here are some examples of VDN provisioning over Creona S. So the Creona S is actually single physical and shared infrastructure, and it can be split into many, logically isolated networks like this. So each VDN has its own network topology to support some, required bandwidth to be guaranteed for their own, applications, services, or experiments, etc. And here is another application based on VDN, that is the virtual network access control. So VDN actually can be interconnected to public internet domain using SDN IP features. But in that case, VDN can be actually vulnerable to the security attacks from outside of SDN domain, from internet. So we need actually kind of virtual network access control to be provided for users who want to actually operate those VDN very reliably. So each users can easily and simply configure their own allow by default or deny by default security policies on each VDN using this application. And the virtual network federation technology is actually implemented and developed mainly for inter-VDN connections with guaranteed network performance between different SDN domains. For example, between national research networks in Korea and China, or between data centers, or between campuses over KREONet-S. So this federation technology is quite essential for intercommunications for individual SDN and VDN domains. And here is VDN and Kubernetes orchestration actually implemented based on KREONet-S. So we developed this VDN orchestrator to interact with VDN as well as Kubernetes to create and provision end-to-end virtualized and containerized resources over SDN-centric wide area networking over KREONet-S. So the orchestrator can interact, Kubernetes and VDN like this. So Kubernetes can create the pod interconnected to KREONet-S infrastructure, and then VDN can, create the virtual network slices over, domestic and international, infrastructure of KREONet-S. So finally, you can have, end-to-end virtual network slices, including, the pod resources as service, resources for users. And here are actually the algorithm we made, especially for auto selection and allocation for the service containerized resources based on two metrics. So we can do the orchestration in a fully, not really fully, but in an automated and actually intelligent manner. So for this way, we use two metrics like this. First metric is location proximity to each end host with specific weights configured on each Kubernetes enabled regional networking centers. And the second metric is the resource utilization. That is actually resource availability of CPU, memory, and storage of each Kubernetes worker node distributed over KREONet-S infrastructure. And so here's the demo of VDN orchestrator we actually implemented. Actually, this orchestrator uses some specific VDN CNI that is designed for provide the dedicated connections for each pod created by Kubernetes. So let me start the demo here. Please run it now. Okay, so we'd like to specify name and service type here, and then input information for some required resources, such as 4-core CPUs, 4 GB memory, and 40 GB storage, like this. And we want to set the host image as Ubuntu here. And we are going to select several end hosts from user side in different locations, like Chicago and Busan, and from Seoul, and from Daejeon. So, and then we want to actually keep the service location as optimum here to be automatically decided using the algorithm I mentioned. So here, pod is created, and you should be connected to one of the locations automatically and intelligently using the algorithm. Okay, here, it just connects to edge node of Daejeon. And we can actually add one more resources and now input information for new service resources like a 5-core CPU and 40 GB, 50 GB storage. And this time, we want to set the location to Seoul. Okay, so the pod is created, and it should be connected to the node in Seoul like this. So it is kind of successfully done here. And then we just create the virtual network slice, including the service resources you can see here. We just created, as we just created. And we want to select the VDN from the VDN list here. So by the name of the new actually VDN all resources, so you can see the brief information here. And we want to visualize the VDN's dedicated network topology. And this network topology is actually including the newly created pod resources, as well as network resources all together. And actually, it also has several VNF, like virtual DHCP and virtual network access control on it. And we actually did this demonstration at the ONF Connect 2018, actually last December, and it was quite successful. And the same demonstration, the location and load-aware virtually dedicated container networking over Carrier S was also performed at APAN 48. That is kind of one of the renowned Asia Pacific research networking event that was actually held in Daejeon, Korea. And here are several use cases for VDN and VDNO. The first one is actually VDN for IoT. Several IoT data centers located in distributed, edge network or regional networking center of Carrier S can be, sliced using VDN for edge-to-edge cloud and the VDN orchestration and federation. And actually, we are still working on it. And so IoT gateways is also can be sliced using VDN and VDNO2. So this is actually specifically for distributed IoT gateways connecting to edge cloud communications. Edge cloud for communication and orchestration altogether. So this could be one example or use case for VDN and VDNO. And second use case would be network intelligence. As I already mentioned, we implemented the VDN orchestrator, VDN manager, multi-node owners, deploy cluster, and Carrier as data plane networks as infrastructure layer. And now we are working on VDN telemetry to collect the data sets from each layer of Carrier S. And those data sets will be delivered to big data analytics for some policy decisions to be generated as actions. And those actions will go to actually VDN orchestrator, and VDN orchestrator provision the proper resources using those actions created by big data analytics and the policy engines. So this could be actually network intelligence use case. And eventually, we want to actually make this control loop for rapid network isolation and dynamic access control. And we are working on some joint research for this network intelligence with several advanced universities in Korea and Korea Telecom for new AI and machine learning oriented virtual network management. So this is kind of network testbed we can actually build up for gathering data sets for the use of big data analytics based on AI and machine learning. Here is another use case that is virtualized edge geoscience TMG. So science TMG is quite not really familiar with you, but it is a kind of scientific storage and computing resources located in each organizations or user sites on CreoNet. So at this moment, the on-site, at this moment, the science DMG actually data transfer node is actually kind of located in each site, and those on-site DTN is now managed by each site and each organization, and it causes lots of cost and actually operational overhead. So we wanted to actually move those on-site DTN to the edge of CreoNet S, and then the virtual containerized DTNs can be generated to be integrated with CreoNet S and VDN environment. So eventually, we want to have end-to-end as in controllable, orchestrated, and virtually dedicated networking actually environment with distributed service resources. And another one is automated VDN, and actually this use cases can be applied for the VDN auto provisioning with several other applications or software externally located. So one of them is actually Global Soul Line. So, but this is quite specific to research community, so I would like to skip it. But I want to say the VDN can be very automatically created and managed. Actually, using this kind of automated manner rather than statically configured actually approach. So let me conclude my talk here. So Clearnet is now moving forward to software-defined interconnections and automated end-to-end orchestration, also to network intelligence. And I hope we can do some joint research or development with telcos and service providers through this actually very renowned conference of SDN and NFV. So that's it for my presentation, and thank you very much for your. Yeah.